Hello, my name is Blanca, and today we're going to discuss a research question that is, what factors explain the change in house prices? So we use pool data, and here we have the variables, which are sold price, which is the price at which the house was sold, the number of beds, the property age, the living area, the number of baths, and the lot area. We have the number of observations of each variable. We can see that there are some variables that are missing, for example, in price sold price. Then we have their mean, their standard deviation, their minimum, and their maximum. So, sorry. So our y variable will be sold price, and our x variables will be the number of beds, the property age, the living area, the baths, and the lot area. So first, we have to run our multicollinearity tests, which are firstly, we have the correlation matrix, which we can see that there are several pairs that present multicollinearity. So pairs beds and living areas, baths and living area, baths and property age, and baths and beds all have an absolute value higher than 0.5, which means that they present multicollinearity. And what we must do now is we must not include the variable baths in our regression because it is present on 3 of these pairs. And also we have another pair that is beds and living area. So what we have to do is either include beds or living area, not both. So what we did was run the regression. Baths we will not include. So what we did was run a regression without beds and without baths, and then we run another regression without living area and without baths. So we saw that the adjusted R squared without the variables beds and baths was 0.5312, which was better than the adjusted R squared when we run the regression without living area and baths, which was 0.1675. So finally, what we did was just not include in our regression baths and beds to fix multicollinearity. Oh, sorry, and then the VIF test, the VIF, because none of the variables were higher, had a value higher than 5, it was not a problem for us. Then heteroscedasticity and nonlinearity. So first we had to take care of heteroscedasticity. So we did 3 tests, the white test, the Bruch-Pagan, and the Bruch-Pagan-LM test. So the 3 of these tests, they all gave us a p-value lower than 0.05, which means that heteroscedasticity was present in our regression. So what we have to do when this happens is add comma robust at the end of our regression, and then compare all of our variables, x and y, to the normal distribution graph to see if they follow a normal distribution with the command k-density in Stata. So we did that and we saw that variables did not follow the normal distribution, and so what we had to do was transform them into natural logarithms to fix heteroscedasticity. Because we did this, for nonlinearity, we should do NL check, which is a command in Stata, of the x variables and look at the p-value. But because we transformed all of our variables because of heteroscedasticity, we will not carry out this nonlinearity check. So finally, you can see that we were left with this regression, which is all our variables as natural logarithms and our time-fixed effects that are necessary in pool data, and then comma robust because of heteroscedasticity. So we have that 3 of our variables are significant, and because they are all natural logarithms, we will interpret their coefficients with percentages. So 1% increase in living area is associated with a 0.840% increase in sold price on average, holding all else constant, and then a 1% increase in the property age is associated with a 0.114% increase in the sold price, and then a 1% increase on average, holding all else constant, sorry, and then a 1% increase in the lot area is associated with a 0.127 increase in the sold price. 0.127% increase, sorry. and the sold price on average holding all else constant. The other two, we will not interpret them because they are not relevant. And um, we can see that our adjusted squared is 0.535, which means that our regression explains 53.5% of the changes in sold price. We can see that the variables that I said were relevant and have the asterisks, which means that the p-value is lower than 0.01, which is very good. So thank you for your time.